Greetings. Let's start with the discussion about determinacy and stability. To talk about the determinacy, we can say when all the forces in a structure can be determined strictly from the available equilibrium equation, then the structure is referred as statically determinate one. The statical determinacy can be viewed in two forms with the help of deformation capabilities, means the compatibility conditions, and the second one equal distribution of the forces, that is equilibrium state. Based on this, determinacy is classified into two forms. First one is static determinacy, which is the difference between the number of unknown forces to the number of usable equilibrium equation. The second form is said to be kinematic determinacy, which is the difference between number of unknown displacement with the number of available compatibility equations. Let's discuss with reference to a figure here. We are seeing a continuous beam having continuous support A, B, C, D. Roller supports are there, over which an applied load P is that the load applied is inclined with reference to horizontal plane. If we prepare free body diagram, we find that there are three forces which are being generated due to the end condition: Fa, Fb, and Fc, which are the reactive forces going in upward direction. Whereas if we see about the applied force can be resolved into two parts, one horizontal component and one vertical component. If you talk about the equilibrium, so equilibrium is not going to be satisfied there because the three unknown forces are there and one available force is there in vertical direction. There is unbalanced two forces remaining in the structure. In terms of kinematic, if I talk about kinematic here, I'm going to find that the horizontal component of this applied force is not going to balance by any restraints available there. That's why it has insufficient constraints. So we can term this type of structure as a statically, your kinematically indeterminate. So based on this, let's go with a term known as a degree of static indeterminacy. If the structure is statically indeterminate, the additional equation need to solve for the unknown reactions are obtained by relating applied loads and reaction to the displacement or slope at different position on the structure. These equations, which are referred to as compatibility equation, must be equal to the number of degree of indeterminacy of the structure. Means the number of equations which we are going to write to obtain the unknown forces with the help of compatibility condition. That number we can say it as a degree of static indeterminacy of that particular structure. In similar sense, we can define a degree of kinematic indeterminacy. The degree of kinematic indeterminacy dk, which is represented by the symbol dk, is the minimum number of movements, that is the degrees of freedom DOF, with which the kinematic configuration of overall structure can be defined. That is, the number of unknown independent movement of the structure will be counted as a degree of its kinematic indeterminacy. Hope you understood. I will be coming up with such short videos in meanwhile to make you understand about the concept related to structural analysis. Till then, goodbye, take care.